5, and what we're going to do is look at properties of logarithms. Logarithms have some really interesting properties that are going to help us to solve exponential equations. You already know, like, if you have x squared equals 7, the way you solve that is to take the square root of both sides. And it turns out that if you have, like, 2 to the x equals 5, the way you solve that is you have to get that exponent, that variable, the unknown, out of the exponent, and you do that by taking the logarithm of both sides. That's called the power rule, and that's a really great property of logarithms. And there's a couple others that we're going to play with today. So it's really just moving furniture, learning about how logarithms can change your equations. Okay, so logarithms were discovered in the 1500s, and they played an important role in the history of science. Kepler used them to calculate the positions of the planet Mars, which led to his discovery of the laws of planetary motion. And Isaac Newton used them to discover the universal laws of gravitation. So although calculators and computers have made tables of logarithms obsolete, applications involving logarithms still play an important role in modern-day computation. And one of the reasons for this is because logarithms possess several important properties. Okay? And so here are the properties. The first one we kind of looked at last time. Remember, it's a to what power equals 1, so it makes sense that a to the 0 power equals 1. So whenever you're taking the logarithm of 1, the answer is always 0. And if you take log a of a, so the same base and you get the base, then that exponent has to be 1. Okay, these next three are the really exciting properties. The log of a product is equal to the sum of the individual logs. That first one is called the product rule. Then the log of a difference is equal to the difference of the individual logs. I'm sorry, the log of a quotient, division, is equal to the difference of the individual logs. So that's the quotient rule. And then the power rule, when you take the log of a base to an exponent, what happens is the logarithm brings that exponent out in front, and so you have r log base a of m. So this is called the power rule. So these are some properties that we're going to play with in your homework. So you're just going to be applying these rules, and sometimes you combine them together. All right, so express as the difference of logarithms. Notice that you have a quotient, so you will just apply rule 3, and you will do this is the log of 26 minus the log of y. Now remember, when there isn't a base, it's understood to be 10. So this is a base 10. You just leave your answer like that, though. That's all they wanted, to make sure you understood the quotient rule. Okay, and now on this one, we're going to use both rule 2, which is the product rule, and rule 4, which is the power rule. So apply the product rule and then the power rule. So the product rule tells us that the natural log of a product is equal to the sum of the individual logarithms. So we can write this as ln x to the 6 plus ln y squared plus ln z, or natural log z. Okay, now the power rule tells us that we can take this exponent right here and bring it out in front, and we can do the same on this one. That's the power rule. Okay, so we'll do that, and we'll get 6 ln x plus 2 ln y plus ln z. So that's your answer there. Okay? Now let's try the properties again. Now this is kind of a combination of all three rules. Rules 2, 3, and 4. Okay, first we'll use the quotient rule. So we'll have the ln of xy to the 4th minus the ln of z to the 4th. So that's the quotient rule. Then I'll use the product rule. So Chilton, do you want to tell me how I'm going to use the product rule?
Would it be ln? Would it be ln plus 4 to ln x y plus ln z 4?
Okay, so ln x plus ln y to the fourth minus ln z to the fourth. Yes, that's the product rule. And then now, Moody, can you tell me how I'm going to use the power rule?
It's going to be ln x plus 4 ln y minus 4 ln z.
Good. So the power rule brings that exponent on each of these terms to the front. Okay, so that was the power rule. Okay. Now it says, use the properties of logarithms. So same thing here. Now this one's slightly challenging, slightly more challenging. Notice it's a base 3 logarithm. And this cube root, it would be better probably to write it like this. Let's write this as log base 3 of 7 to the 1/3 power divided by y squared r. That's the first thing I'm going to do. Now I'm going to apply the quotient rule. So I'll have log base 3 of 7 to the 1/3 power minus log base 3 of y squared r. Now I still have both the power rule and the product rule to use. I'm going to choose to use the product rule first. So this will be log base 3 of 7 to the 1/3 minus, be careful here because I'm subtracting this entire product. So this is going to be the sum here, log base 3 y squared plus log base 3r. And now I'll use the power rule. So I will have 1/3 log base 3 7 minus 2 log base 3 y. And I'm going to distribute that negative through, and I get minus log base 3r. So this was the power rule. I'm sorry, let's see. So I did the quotient rule first, and then the product rule, and then the power rule. Okay, so the product rule I applied to this part right here, and then the power rule was for this one and this one. Okay, and notice that that cube root of 7, I decided to think of that as 7 to the 1/3 power. Okay. So this one, the way you want to write it first is to think of this as log base 3 of rz over 2 to the 1/2 power. Because of the way this is, you're going to need to do all 3 rules, but you're going to want to do the power rule first. So we'll do power rule first. So we'll bring that 1/2 to the front, and we'll have 1/2 log base 3 rz divided by 2. So this 1/2 is going to be on every single thing that, it's going to be multiplied by all of them. So now if I apply the quotient rule, I have 1/2 onto log base 3 rz minus log base 3 of 2. That was the quotient rule. And then this 1/2 tags along, and I can use the product rule right here. So this is log base 3r plus log base 3z minus log base 3 2. And that is the product rule. Okay, now we're just going to go back the other way. We have the sum of individual logs, so we can use the product rule to write that as a single logarithm. So we can write this as log 16 times 20 with the product rule. And then you can go ahead and figure out that that's log, let's see, was that 320? Because you can multiply those. All right. Chilton, do you want to help me do number 7?
Yep.
Yes, sir.
Negative 36. Log negative 36.
Okay, now since we have the difference of individual logs, when we go up here, we see rule number 3 tells us that the difference of individual logs is equal to the single log of the quotient, or the division of them. So go back to that and tell me what you think.
It'll be log 9 over 4.
Yeah, log, and it's base C, 9 divided by 4. That's using the quotient rule. Okay, Marlon, do you have an idea on number 8? You have to use 2 properties. Do the power rule first.
So you take the 2.
Yeah, you're gonna bring that 2 and you're gonna put it up into the exponent. Oops.
Mm-hmm.
All right, so this will be log base b of x squared minus log base b of y. That was the power rule, kind of in reverse from how we looked at it before. Now, apply the quotient rule and tell me what we'll get.
Would it be log b then the x squared over y?
Good. X squared over y. So that is the quotient rule. Okay. On number 9 then, you should see that since we have the sum of individual logarithms of the same base, we can use the product rule. And we'll write it as a single logarithm. We'll write it as log base 10 of x plus 6 times x minus 6, which is log base 10. If you FOIL this out, you'll get x squared, and then you're going to get minus 6x and plus 6x, so those will cancel, and then minus 36. Okay? Now let's use the properties of logarithms and then see if we can find a graph of this next one. Okay, this one's going to be pretty complicated. We've got a power rule and let's see. I'll pull this up into the front. So this will be the log base 5 of the 5th root of x divided by, 5th root of x minus log base 5 x to the 4th. Then I'll do log base 5, the 5th root of x divided by x to the 4th. Now, you actually want to clean this up some more. This is log base 5. This is x to the 1/5 power over x to the 4th. And what you can do there is, yes?
What about the 15?
Oh, yes, you're right. I'm sorry, I was thinking that was the problem. Okay, so I've got a 15 there. So let me use the power rule to bring that up front here. And I'm going to go ahead and write this to the 1/5 power then. So how about I write this as x to the 1/5 power, and then that's to the 15th. So that'll be log base 5, x to the 1/5 of 15 is 3rd, minus log base 5x to the fourth. Now I can use the quotient rule and write this as log base 5 x to the third over x to the fourth, which will be x to the third over x to the fourth is x to the negative 1. So this is log base 5 x to the negative 1, and your negative 1 comes in front, so this is negative 1 log base 5 of x. And so it's log base 5x, and then you're going to reciprocate it. Or I guess, no, okay. And so that's it for that problem. I guess this next one, I'm kind of squished over here. That's number 10. Let me get to number 11. Hopefully it'll let me. Okay. Okay, so now let's look at number 11. It says, choose the graph of log base 3 of x. And so remember, we don't know just yet how to graph this on our calculator. So you want to consider 3 to the x, because that's the inverse function. And so if you think about 3 to the x, if you pick some numbers, negative 2, negative 1, 0, 1, 2, you'll get 3 to the negative 2, which means 1 over 3 squared, or 1/9. 3 to the negative 1, which is 1 over 3, or 1/3. 3 to the 0, which is 1, and then 3, and then 9. So if you plotted the exponential function y equals 3 to the x, you'd have negative 2, 1/9, negative 1, 1/3, 1, 0, 0, 1, 1, 3. Let's see. And anyway, that's enough points to get us kind of going. That's your exponential function. Now remember, your log function is a reflection of that function across the line y equals x. So instead of the point 0, 1, you have the point 1, 0 on the graph. And instead of the point 1, 3, you have the point 3, 1 on the graph. And then instead of the point negative 1, 1/3, you have 1/3, negative 1 on the graph. So anyway, you should get the idea that it's going to look like this. That's log base 3 of x. So that's choice D. Okay, now this next formula is going to help us able to graph anything now in any base. This is really exciting. Log any base of x, you can change that to any other base by saying log base b of x over log base b of a, where b is the base that you want. So the two bases that we have on our calculator are the base 10 and base e. So if you wanted to do base 10 to help you figure out what log base a of x is, you would do log x divided by log a. Or you could do ln x divided by ln a. So if you, for example, say you want to do log base 2 of 8. You know the answer to this. 2 to what power is 8? You know the answer is 3. We can use our calculator, though, now to give us that answer. We do log 8 divided by log 2, and it will give us the answer 3. We could also have done ln of 8 divided by the ln of 2 and gotten the answer of 3. So basically, this gives us a way to answer any logarithm question. So this is log 8 divided by log 2, and we get 3. Or we could have used ln. Okay, so this is kind of fun now. If you want to do the log base 2 of 20, how are you going to do that? Chilton, do you want to tell me?
Log 20 divided by log 2.
Good. Log 20 divided by log 2. And if you wanted, you could have used ln. It doesn't matter. Log 20. You have to use the same thing on the top and the bottom. Divided by log 2. And so that is 4.3219. And so let's not forget what that means. That means that if I raise 2 to this power, I should get 20. So if I raise 2 to the, and it won't be exactly right because I have to round it, 321928095, I get 20. Okay, so it's kind of interesting. All right, and so then log base 3 of 90 is going to be log 90 divided by log 3. And you can't reduce or anything. You just have to type it in like that. So this will be log 90 divided by log 3, which does give you 4.0959. So that's 3 to the 4.0959. Okay? All right, so that's it for this section.